So this problem, I don't think is too bad, but the very last sentence, what they're asking for, actually causes us to have to do a little bit of work. So let's read this question together. It says that two lenses shown are illuminated by a beam of parallel light from the left. Lens B is then moved slowly towards lens A. So lens B is going to be moved slowly towards lens A. And we want to know what happens to the beam emerging from lens B. So we got some answers like it's always diverging, it's always parallel, it's initially parallel, then diverging, converges, and then finally does something different. So let's try this. So what do we know? Well, in order to solve these problems, I always solve the first lens first and then the second lens. I'm going to be very careful of how I treat this. I'm going to be very careful of how I treat this distance d. So the first part that I'm going to do is I'm going to look at this first lens. And I know that with any lens, 1 over p plus 1 over I is equal to 1 over f. And my original distance to my object, because my light is coming in parallel, this is going to imply that my original distance is infinite. So that means 1 over I is equal to 1 over f. So I know that this is 1 over infinity. 1 over infinity is essentially 0, so I get 1 over I is equal to 1 over f, or my image is going to show up at my focal length. So that means that my first image, I should probably subscript these with 1s. So that means my first image shows up at 50 centimeters. So in my picture, that means my first image shows up way over here. 25 centimeters, I'm actually at a distance of 50 centimeters. So 25 to get here and an additional 25 to get there. Now I want to be careful because the next step is going to determine how hard it is to actually do this next step. I know that the image of the first is going to be the object of the second. So they're going to be at the same location, but I'm measuring them different. I measure my first image distance, I1, in that direction, and I know that I normally measure my second image distance from lens 2. I'm going to still measure it from lens 2, but that's going to be my object distance from lens 2. And it's in the minus direction because I know that if I'm on the left side of the lens, it's positive for objects. If I'm on the right side, it's negative. So I need to have a relationship between P and D and I to get this to work. So let's try one, make sure that I get it. So D is the total distance. If I subtract off what I is, I1, this should get me my distance of P2. And I put this minus sign in here just to remind me that it's a negative value. So let's check that to make sure that that negative value works. So my distance between the two is 25 centimeters. And my original image distance, which I just solved for, was 50 centimeters, which means my P2 is a minus 25 centimeters. And that's what I was expecting. I was expecting a minus sign to show up there. So P2 is equal to minus 25 centimeters. More importantly, I like this equation because I'll be able to plug this in and see what happens as I move this lens. As D increases or decreases, I'll be able to see what happens to my final image. So I get 1 over P2 plus 1 over I2. The relationship between the object and the image is proportional to 1 over the focal length. So 1 over P2, and I'm going to just go ahead and substitute in this value, P2. I know that value is a negative number. My image is what I'm looking for, and that's going to equal 1 over F2. F2 is a negative number, but that number is never going to change. So if I plug in the numbers, I will see that this value right here, let's slide everything up so we can see what we're doing. So this is going to be 1 over negative 25 centimeters plus 1 over I2 is equal to 1 over minus 25 centimeters. Minus 1 over minus 25 and 1 over minus 25 cancel out, and that leaves me with originally I2 being at infinity. 1 over I2 is 0, so I2 has to be infinitely large. So that means it's going to initially come out parallel. Parallel in, it focuses, doesn't quite get to a focal point because then this lens will unfocus it and cause it to go parallel out. So we get to this parallel out case, which means it cannot be diverging. It cannot be initially converging because it's initially parallel coming out. It might be always parallel, and it might be initially parallel then diverging. So let's go back up to this equation right here. We see that if d gets smaller, and I is a positive number, that means this value gets more and more negative. As this gets more and more negative, this number gets less and less negative, because we still need to maintain the same value. So as d minus I gets larger in a negative number, so the magnitude gets larger, that means this number becomes smaller. Let me think about this again. If d gets larger, this whole value gets more negative, which means this thing has to get less negative. So I2 has to decrease. So if I2 gets less decreasing, I2 is originally 0 or infinite. That means we're going to slowly go to more and more diverging. Now, if you wanted to check this, you could always throw in some numbers. Say instead of using 25, we could use 20 centimeters, and we'll see what happens to these values if we use 20 centimeters. We'll see that it becomes originally parallel, but then becomes more diverging.